Hey class! So today's video is part 4 of the Parametric Pavilion series. Today's video will be covering how to influence your adaptive shading devices, your adaptive families, with some different influencers, some point attractors, curve attractors, and also using Ladybug's sun path tool to track and influence either open or closed your shading devices depending on where the sun's path is. So to get started, we'll open up Grasshopper. I have the project that we had worked on up to this point with the panels and the structure already on. And I have Grasshopper already open. If I can maximize it, there we go. All right, so we already have the glass glass panel created, but we're going to have to do basically this same exact script, but with the shading device that you guys create instead of just the plain glass panel. Obviously, that's only if you did two independent families. If you did one family, you'll only have to do this once. But so we just copy and pasted the deconstruct brep down to the add component adaptive, and then we'll just change the element type picker from the glass example to the panel example. I think the panel example. I have two shading devices. Let me just check again. Yeah, so this one. I had created a more complex one, but it was a little harder to visualize how it was influencing. So I just made this more simple device that just is a really simple open and close. Open and close. And then obviously in between. Now, if you see here, the thing that I am influencing, the thing that I am manipulating, the variable here is from 0.5 to 1. And realistically, it's 0.501 to 0.999. Because if I go to 1 or 2.5, it's going to error out because the geometry becomes unsolvable, essentially. So when I do my parameter, set up my parameter, I'm going to make sure to do it between 0.5 and 1. Obviously, if you guys have your parameters set from 0 to 1 or even from 0 to 5 or whatever it is, be cognizant of that and update your scripts accordingly. But mine is going to be from 0.5 to 1. So that one, load into the script. That one is called just the panel example. So I'll maximize this again and change it to adaptive panel example. And then going to enable. Okay, so let's check this guy out. All right. So we can see, I'm gonna pin this real quick. Oh, and this is a really good tool just as a sidebar. So I have this floor on here, so I have basically a ground plane. If you pin an element and then go down here to these buttons down here and then uncheck select pinned elements, what that will do is that any elements that are pinned you won't be able to select. So I can click all around my my pavilion, and even though I'm technically clicking on the floor, it's not selecting it. This is really important when you're trying to do things within your projects and you have a lot of components or elements on top of each other, and you want to like click and drag and select all. It can really help because I've didn't know that for a really long time, and it was always a pain in the butt. So right now, select one of these. Oh, I can't select it because the pin now, of course. So that looks to be right. Obviously, if your panels came in and they're facing the wrong way, if I go back to Grasshopper, remember you can reverse the list. Reversing the list will basically place it backwards. the points backwards, and orient the panel on the opposite side of the surface that you have. All right. So now that we've done that, remember you unenable the component once you have it set, so that it stops referencing this component. And this is really important once we get to the step where we're actually influencing those panels' parameters. All right, so the first thing we shall do is let's do a point attractor. So the first thing I'm going to do is I'm going to get the center of all of the different panels. So I'm going to take faces and plug this guy in. Now I have the center of each panel. Basically, I just need a point on the panel to then be able to dimension from a point. And then I'm going to do a let's see, what is it? MD slider. Let's go, multidimensional slider. All right. So what this does is it basically just lays out a point on a XY grid, essentially. But what we can do with this is we can orient it to a surface. So if we do a evaluate surface component and plug in our original surface, to our point. Oops. And before we do that, what we need to do right now, this is a between 0 and 1. Basically 0 to 1, and depending on where we move the point, it manipulates the XY values for that. What that means is we need to reparameterize this surface. Basically what this does is let's see how to describe this. Basically, it resets its UV values from 0 to 1 instead of 0 to 12 or 0 to 20 or whatever it is. It'll reset and reparameterize to 0 to 1, so that if this value is from 1 to 1, it'll be on the far side of the UV values, and if it's 0 0, it'll be on the opposite, and obviously if it's 0.5, it's going to be right in the middle. And if we switch to our Rhino window, let's see, open a viewpoint. Oh boy, I'm gonna have to hide a bunch of stuff. Probably all this, guys. All right, so now you can kind of see it. This is the point. And so as we drag it, it moves along the surface. So realistically, it can actually be more like, sorry. If we're looking at this relative to this guy, as we move it to the left, come on. Oh wow, this is real backwards. Maybe it has to be like this. Sorry about this. But you get, I usually like to try and orient the graph so that it matches or matches up with somewhat the geometry of the panel, so that you can really get a sense of what it is now, obviously. See if you do this and you rotate it back around. I swear if this does not work, then I'm just going to. Of course not. In any case, you understand the point. So you can move this point anywhere on the surface and it will, or anywhere around the MD slider, and it will move around the surface. So what we can do with that is we can then use a component called closest point. So I'm going to close out this graph mapper and make this bigger. So we can use closest point. Oh, no. And be sure not to click closest points because that is a different component which we will use in a moment. So we'll plug in the point that we get from this evaluated surface into here, and then plug in these centroids into the cloud. All right, so now what we're getting is a series of distances between this point and all of the centroids of the panels, right? So the panels that are closer to this point are going to have a lower distance, and the ones that have are farther away are going to have a higher distance. So we can then use that. I mean, it's a relatively straightforward attractor logic, but we can use those numbers to then remap them from the range that they are currently in. And let's see, we can use the component bounds, which gives us our minimum and maximum. Let's flatten this guy, otherwise it's not going to give us one. There we go. So the distance between these points are between 2.5 and 174.5, right? So we're going to take those bounds and we're going to remap them. Remap numbers. We're going to take this in. We're going to plug all these values in. Then we're going to plug in the source domain, or the source bounds of that list. And then we're going to plug in a target. And the target is what the parameter of the shading device calls for, right? So for me, for this family specifically, it is the NCP high, and it is the 0.501, or any number above 0.5 to any number below 1.0. So I'm gonna create a range from, or a domain, excuse me, from construct domain from 0.501 to 0.999. Plug that into my target. And so then we have a list of numbers that match proportionally the distances and the values within this list, but from between these two numbers. And then we can use those to then plug into our parameter. So we need to do a, let's see. Before we do the actual element parameter, in the example that I put together, and I think this is probably a good strategy for a lot of you, is to put together a quick tester before you plug it into your panels and have your machine run forever. You can do a real simple scale component and use the panels, the faces from that Deconstruct brep in the scale. So plug that into the geometry, then plug the center as the centroids of all of those panels. And then the factor, we could plug this in, but to have it be a little more representative of what we're going to do, we're just going to copy these two. actually copy these three, sorry. Plug this in, plug this in, and then this domain is going to be between 0 and 1. Actually, sorry, 0.01 and 1. If we do 0, it's going to give me an error on a couple of my panels. All right, so now that we have these remap numbers, we can plug that into the factor, and then what this will do is it'll scale all of those singular surfaces down and give me a preview, essentially, of how that attractor is influencing our panels, and making sure that before we plug it into the more the heavier and the more CPU dependent element parameter component and influence all of those Revit geometries, we can preview that really quickly in the Rhino environment. All right, so I did something before I should have, or I did something dumb. It just ran forever, and I realized that's because I did not flatten the geometry in centers. So before I do that, I'm going to disable the solver so that I can do both at the same time and not have it run again for a while. Undisable solver. All right, and that ran about 100 times faster. So if we preview down and turn off, turn back on. Yeah, unpreview this. There we go. So now we can see how our panels are going to be influenced and make sure that our point component or our point attractor is working correctly. And we can see how it influences the components as we influence. And this is a really good way to get it in position before and not have to continually redo the element parameter component. So once we get it into once we get it into a spot that we like, then we can unpreview this. I'm just going to break this out as its own separate thing because we'll use that to test each one of the different attractors that we'll be developing today. So then we're going to create the element parameter. So we'll do a category and set a generic model. Should be pretty familiar by now. Element type picker. Plug that guy in. Pick our shading device. Now you could obviously use the same one that we had used previously. Type filter. So this will start to filter out all of the different elements that have this type. So that's the first part of it, and then query elements is the second. All right, and then element parameter. So these are our elements. Our parameter is the NCP high, so I'm going to do 2 backslashes to bring up my panel, and then NCP high. Remember, oh geez, NCP high, not height. Remember that both capitalization and spaces are going to affect your component and your parameter. So make sure that there are the same number of spaces and the same capitalization. All right, and now that I have that plugged in, now I'm going to take my mapped numbers, the one that are from 0.5 to 0.99, and plug those in. Now this one's going to take a little bit. All right, so it's ran, so I'll check. And let's just go to a top view really quick. so you can start to see change. It's hard to see because they're also rotating too. But let me just select, let me undo the pin, let me just select, make sure. Oh, that's weird. Oh, now I'm gonna have to diagnose this. Hold 1 second. I remember. All right. So because there's a limit on this guy, so remember, Rabbit's trying to be smart, or I guess Grasshopper is trying to be smart. So it's putting a limit on how many elements it queries, and so it was only giving me 100 panels coming out of the query elements and putting in, so obviously only then the first 100 panels were being influenced. So just increase that limit to a little bit higher than the total amount of panels you have, and wait for it to run. All right, so now we have 360, we have 360 values. All right, that looks a little better. Yep. So now if we check these guys, yeah, we have a series of parameters getting larger and larger. All right, so that is the point component. And now for some reason I have a space frame on the other side of my, that's weird. All right, sorry about that. I had opened up my old reference script to check something, and it must have regenerated the panels on top. That's why it's so hard to read, but there you go. All right, so that was a point attractor, excuse me. So now we will do the curve attractor. So it's pretty similar to the, I'm gonna put this over here, pretty similar to the point attractor, but we will use a curve that we generate in Rhino. So we're just gonna draw a basic curve. I'm gonna draw it in plan. Turn ortho off and just draw curve like so. All right. And then I'm going to import that into Grasshopper. If I can get it to, this is fun. There we go. All right, import into Grasshopper. So just do a curve, set one curve. All right, now I can minimize this and bring back Grasshopper. All right, so now I have my curve. So now I can use what is called curve closest point. All right, find the closest point on a curve. So I have my curve, and now what I'm going to do is plug in all of those centroids from the panels into the points. Plug that in, and then I'm going to use, so this is basically orienting or identifying a series of points along this curve closest to all the center points in the panels. That's going to give me not only points but also a distance. So then closest points, no, one closest point again, then I can use the point from here to here and then use the centroids of the cloud. And then use the same thing here. I'm going to take this whole series, the construct a main bounds and remap numbers, copy and paste that. Use the same thing, distance, value. I'm going to flatten this guy. Distance, there we go. All right, and then it'll give me the same amount of remap numbers. Now again, I'm going to plug this into my tester here. Bring this guy down. If I really wanted to be special, I would create my own unique component, but all right, we're going to take the remapped numbers, plug this into the bounds and the value. And let's see what it looks like in Rhino. Let's pull up that preview again. And we got actually. All right, so we can see that it is responding to the curve as we move it. All right, so then if we get in position, now that we know that it's working correctly, we can then do the same thing and plug these remapped numbers in for the value. All right, so now we can then see it is now working. Now, this one is doing the opposite of what our sample is, right? So it's open on the two corners and closed in the middle, where this one is more open in the middle and closed on the ends. Remember, if you want to reverse that, all you have to do is change these two numbers, or excuse me, that's the sample, where is it? Sorry, these two numbers. So if you want to have it be the opposite, I'm gonna turn this solver off right now. You basically put 0.99 at the start, 0.5 at the end, and then re-solve it. All right, so now minimize. You'll see that it has reversed. Now it's more open in the middle and closed on the ends. All right, so that is the curve attractor. Now we will get into the final influencer of the, not a social media influencer, but a information data influencer with the sun path. So let's preview this. And first we'll start off. Again, we're only using the legacy Ladybug and Honeybee tools. The newer versions do not work in Rhino Inside. So we will first, did I set up I don't think I have to set up a Ladybug tool, but it wouldn't hurt just to have it out. So I'll start with that. Ladybug. And it's underscore Ladybug. There we go. All right, and then we're gonna use an EPW file. So Ladybug import EPW, use our file path. We're gonna set one existing file. I'm gonna use the Charlotte one we always use. So then what we're gonna do is plug in our sun path, Ladybug sun path, plug in our location. And then I'm gonna set a couple parameters for the hour, day, and month. So remember, this tells you the number range, so 1 to 24 for the hours, 1 to 31 for the day, and this is airing out because there is no sunlight at hour 1 ever. And then the month will be 1 to 12. So let's do somewhere around there. And we can actually do probably 9 to 6, let's say. That's a good hour range for our sun. And then month we can do, I'm gonna do my birthday, 6. All right. So I think, let's see. Oh yeah. So then quickly we'll do a center point. So I'm gonna do a area, and I'm going to plug in surface. And then what this does, it gives me a center point. You can't really see it. It gives me a center point around the geometry. Now the problem with this is that let's see, deconstruct point. There you go, deconstruct point. So what this gives me is the center of the surface, not only in the XY but also the Z. But we want our sun path to be on the ground. We want it to be on Z equals 0. So what we'll do, we'll deconstruct this point into its XYZ and then essentially reconstruct the point. But instead of plugging in all of the points, we'll just plug in the XY, and the Z we will keep 0. Alright, so now that we have that, we can plug that into our center point. Now we want to use the center point so that we can see in our Revit model and subsequently our Rhino really clearly where the sun is. So dependent on where our hour is. Oh, I screwed this up. I put 9 to 6, but it is actually 9 to, what is that? 19? No, 18. There we go. So as we move this slider, the sun, you can see by this yellow ball, moves across. Then obviously if we adjust the month, we'll move across that way as well. All right, put it back to my birthday. All right, so now we have, and we can also scale this guy down to be a little closer. So let's just do a half. A little bit. That's good. Okay. So now we have our geometry and our sun path. Close this guy out. It's a lot nicer. Okay. So what this sun path component outputs is a couple different things. Obviously it outputs a lot, but the two things that we will use is the sun sphere mesh and the sun path center point. So what we're going to do is use a mesh closest point. We're going to take this mesh and also take the center point of the sun path. That is essentially this guy right here. It's going to give us a point on the mesh closest to that point, so it's going to be point about there. Basically, this is giving us a point that is in the relative position of the sun compared to our geometry, our pavilion. Oh, and then we are going to do, let's see, what are we doing? So what we're going to do is I'm visually going to show what am I doing? Sorry, I'm reading my reference. So what I want to do, there we go, is do a line, start and end point. And I'm going to choose the start as our closest point, and then I'm going to put as the end our centroid again. So if we find our centroid component of all of our panels, plug that guy in. So then now we have basically a vector coming off of all of these panels to the sun's position, and it will essentially track the view corridor of the panel to the sun. And what we can do is we can essentially take, right, if our panel, this panel here, our normal or the perpendicular line off the face of the surface is straight up and down, and then the angle to the sun is at this skewed angle, we can measure the angle between the two and use that angle to then influence our shading device, so that the panels that are, you know, facing farther away and have a greater angle of incidence away from the sun will be more open and allow more naturally diffused daylight in, and then the ones that have a more direct angle to the sun will be closed because it's trying to shade as much of that direct sunlight as possible. All right, so we will open up our Grasshopper script again. All right, so what we're going to use is an angle that measures the angle. And we're going to want this one. So compute the angle between two vectors. The first vector is going to be that line that we just created. And then the second one is going to be a evaluate surface component. And we are going to use, instead of the full surface like we did with the closest point, we're actually going to take the deconstructed base point, plug that guy in, and then our point that we're going to evaluate is actually going to just be the midpoint, or the closest point. So what we can use is a panel that uses the 0.5 to 0.5 to 0, and all right, so make sure you are matching. Oh, got that weird funky, go away. Okay, make sure it matches this guy. I think I have one too many spaces in here. Yep, make sure it matches this, plug that into the point. Now we have the midpoint. And the reason why we have to do this evaluate surface instead of the area, getting the centroids, is because it gives us a normal out of all of those different panels. The center of all those panels is giving us a normal, which gives us the second vector that we can then measure from. Now we have 360 angles that we can then transfer. Now remember, all the angles are going to be in degrees, so we can either, oh, it won't give us that. Okay, well, oh, sorry, we need to do the opposite. We need to plug, this angle is coming out as radians, so we need to transfer the radians and convert the radians into degrees, and then we're going to do a quick if-then statement. So if we pull up the expression, I'm just going to close these for right now. Double click to open that up. And then if list is, ooh, that's weird, list or whatever is greater than or equal to, so I'm going to find that up here, larger than or equal to 90 degrees, then I want it to change to 90. And if not, then it's just going to revert back to list. And then I'm going to do a plus and change this input to list. There we go. So what that is doing is, and I've gone through if-then statements a little bit before, but what that does is if a value coming in is greater than 90 degrees, it's going to automatically change that into a 90 degree. Let's see. I think this might be. Oh, all right. Hold on. Let's reparameterize this. And then, yeah, it's still. I wonder if the normal is coming off backwards, or not backwards, but yeah, let me just visualize these vectors really quick. Just doing a line start direction. Should give me, and let me do a length real quick. Sorry thanks for bearing with me real quick. No, that's right. So why is it giving me? It's really crazy. Let me try switching these. All right, I figured it out. So you need to flip the curve. If you're getting numbers that are greater than 90 degrees, you can just use a flip curve component and flip that start endpoint and plug that into the angle, and then you will get that degree. So now if you can see, if there is anything over 90 degrees, it'll be 90. There's only the one. And then now we can just do a bounds, or bounds. Oops. Or actually, hold on. Just copy and paste this guy down. Oop, sorry, wrong one. This one down. The 0.99 to 0.501. Flatten this. Alright, and now, as we've done before, pull our tester group. And obviously we could have done this before, but we can group it. And change the color to something a little bit more. Alright, so plug our map to numbers into the bounds and the value. Preview this. And also unpreview these. Oh, I need viewport on. All right. So, oh, what I do need is the sun on. Let me split screen this. So let's see if I track it across the sky. Look at that. All right. So that's perfect. So now we will unpreview this and plugged these map numbers in to our element parameter. All right, and now if I close this and minimize this. All right, so now it's doing the opposite, where it is being open, where it needs to be closed. This is that weird thing. I don't know what it is, but so we will go back and switch this. Recompute it. All right, so now, yep. So now we have it closed when it is in more direct sunlight and open when it's in less direct sunlight. All right, so those are 3 different ways of manipulating your adaptive components, your shading components, either with a point attractor, curve attractor, or a sun path.